Right, so a quick formal introduction to this space, and then we can get to the meat of the conversation today. So we're talking with Todd Chapman, the Chief Technology Officer of Snickerdoodle Labs, on the topic of building a ZK application with o1.js, which is an SDK from o1Labs. I'm Phil Kelly. I lead business development at o1, and I'm here with my colleague from the technical engineering side, Jack Servia. We're planning on talking for about 30 minutes before opening the conversation up for wider participation. So looking forward to hearing views from other people. We have a blog post on this topic, in fact, for today. We published it about a month ago, and it includes both a quick recap on the business side and the technical side too. There's an interesting snippet of ZK code in there. So that's something that people could find it useful to reference. This is the second in a series of weekly spaces with projects that are in the o1.js partner program. We talked with Paradise last week, for example, about proof of liabilities. And the partner program is here to help existing projects, Web3 projects usually, as they get experience building ZK applications that run on the client side. So that's the way in which you can build privacy into Web3 applications and more generally build code that can run off chain. And that's how you can avoid gas costs and reduce latency and avoid some of the data challenges that you get from working on chain. But it's still trustless, and you can verify results back on chain. So it's a very, very interesting approach to building all kinds of new things. And it's not just about privacy, but privacy is definitely the main topic today. And the goal of this series of Twitter spaces, all of what I've just said, I know is sometimes counterintuitive to people in the Web3 space, and is also maybe a little conceptual. So the goal of these conversations is to bring that approach to life with examples. So very happy to have Snickerdoodle on the call today. Just a quick reminder of what o1Labs does. In addition to building the o1.js SDK, we're the engineering team behind the MENA protocol, which was the first ZK-based L1 and is now in the late stages of testnet for an upgrade that will make it a great place to verify and settle a ZK application. So that'll be a new superpower to the world. We're also looking at new approaches to ZK, client-side ZK. And that's part of the motivation behind our recent work on adding ZK capabilities to Optimism's fault-proof engine. The results of that will be synergistic with MENA's ecosystem, and in particular, it will extend the use of the Plonkish ZK proving system that we've got that's powering o1.js and the MENA protocol. Okay, so let's turn to Snickerdoodle, and the particular ZK app that Snickerdoodle has built is part of a new approach to marketing based on browsing behavior, but without Web2 cookies that follow you around the internet, and with customer permissioning and respectful privacy. So Todd, let me turn this over to you to introduce yourself personally, and then maybe give a more comprehensive explanation of Snickerdoodle.
Great. Thanks, Phil. So hi, everybody. My name's Todd. As Phil said, I'm the CTO at Snickerdoodle Labs. Joined the team in May of 22. And a little bit about my background. I come from an applied math background. I did a PhD in aerospace. So I've been doing computational work for a long time. I was introduced to kind of the area of smart contracts around the 2017 timeframe from a friend. And that kind of took over my life, and that's what led me to go into like the general Web3 crypto blockchain space. And I've been working in Web3 since 2018, so been here a while. Now at Snickerdoodle Labs, what we've been building, we've built what I call generation data management platform. So for people that are listening that aren't familiar with what a data management platform is, there's these things out there like Twilio Segment, like AppFlyer. Probably you're familiar with things like AdSense and Google Analytics. These are consumer data management platforms, and they help your typical small, medium, and large enterprises better understand who their users are, how to engage with them, what they're interested in. That's what a data management platform does. And so we built a next generation data management platform that does not rely on first or third party cookies. So I'm sure everybody's, come across a website before where it pops up and says, "Do you accept our cookies?" And you probably click, "Yeah, sure, just get this out of my face." Well, once you do that, you've got a cookie that's associated with your user profile that's sitting in your browser. And then that cookie follows you around the internet, and it allows third parties to basically track everything that you do, because you forget that cookie's sitting there. So we built a new approach to a data management platform that doesn't use first or third party cookies whatsoever, number one. And then number two, it doesn't rely on centralized custody of user profile data. So with traditional data management platforms, there's some central enterprise, some company that, through monitoring what your cookie is doing across the internet, it builds up an extensive user profile on what you've done in the past. And anybody with basic machine learning or statistical capabilities can probably look at that profile that's been collected by this agency and figure out who you are. So Snickerdoodle Labs is taking a radical new approach. Number one, we're replacing first and third party cookies with zero knowledge proofs, and we're basing that part of our stack on o1.js, and it's been great to use o1.js, number one. And then number two, our data locality model is, maybe I'd go so far as to say, a first of its kind, in that we actually have built a client-side library that allows end users to actually accumulate and custody their own profile information, take it with them from one app to another. Whether it's Web3 or Web2 is actually irrelevant in our use case, but we actually enable end users to custody and own their own profile information for use in our decentralized data management platform. So we fill the same business role as something like a Twilio segment, but we're based on entirely brand new Web3 cryptographic technologies like ZK Snarks from o1.js and decentralized a decentralized data model. So that's my quick ramble on myself and Snickerdoodle Labs.
Yeah, that's cool. I mean, the thing I like about this use case, I mean, so there's a lot of narrative in the industry, and I'm certainly part of it, about the importance of privacy, but it kind of gets presented in a abstract way. And the thing I like about your use case is that it's very concrete, and people can start to think about the value attached to their privacy, rather than I wish that my information wasn't out there in a segmentation database of the old school kind. Because we all know that the online data industry is enormous. It's probably, have you ever looked at what it is in terms of total size?
It depends on where you want to slice it, but the general consumer data vertical is somewhere in the $1 trillion market cap. I mean, it's an astronomical number in terms of the amount of value that is in global consumer data nowadays is astronomical. It's kind of not even worth trying to pinpoint a number because it's so huge.
Yeah. And so today, I mean, obviously some of that market size relates to just the mechanics of collating and using the data, but some of it relates to the value of the data itself.
Right.
And so the interesting thing is that the more that projects like you help users and consumers have some kind of control over the data, the more they're going to realize what that value is and be able to leverage some of it, as opposed to simply getting tracked and advertised to.
Yeah. So, and then another interesting topics in this space is that because before relatively recently, you could not build privately verifiable computation applications whatsoever. I mean, o1JS, its previous incarnation, Snarky.js, this did not exist before 2020. So last decade, you could not have built apps like what Snickerdoodle Labs is building right now. And the centralized nature of the consumer data industry just inherently leads to a lot of bad behavior, things like click farms, bot networks, things that really affect small and medium businesses that are trying to legitimately use digital advertising, recommendation engines, things that help them get their business out there and get customers. The old model of data locality and centralized ownership of user profile data inherently led to just kind of bad behavior by a lot of bad actors out there. And I don't know if we can solve all of them with zero knowledge proofs, but I think by removing a lot of the middlemen in this space, you have a hope of solving some of these problems that arise in the current consumer data marketplace. Things with click farms, bots, stuff that wastes small businesses, that waste their money when they try to use these important business tools. I think we can actually solve a lot of those with this new zero knowledge proof technology.
So, which is to say, it's not. I mean, I was talking earlier about the potential value to users and customers, but your point is that there's also new possibilities for the businesses and the sites themselves, because you can maybe have a better approach to proof of liveness and
so there's certainly that, right? You're certainly going to improve the value that businesses can get out of using a data management platform service. You're certainly going to improve the value here by introducing verifiable computation technology into the stack. Yeah. Now, end users are absolutely going to benefit from this as well, but here it's going to take some prolonged education of your typical end user, because your typical end user kind of does what I was saying earlier, where you go to a website and it pops up, do you want to accept the cookies? And you say yes, right? And they don't give another second thought about it. Certainly there are power users out there that really do care about their privacy. And they use, they use things like DuckDuckGo, right? They don't use Google. They use privacy-centric technologies. And Snickerdoodle Labs has those kinds of users covered, because we let you own your profile data by default. But lots of users we've found are passive at best in caring about their privacy. So being private by default, we're helping those people out. And when they come around to understanding what the value is to their user profile data, we're going to have, through our use of technologies like o1JS, we're going to have them covered as well.
Yeah, that's very cool. The other thing I like about your solution or your use case is that, I mean this in a good way, like right now, it's a very tactical implementation of client-side ZK. So we talk about, there's a whole range of use cases that we talk about. Sky's the limit in terms of the innovation that people can do with client-side ZK. Some of the use cases we talk about require, very extensive rebuilding of an application with ZK all the way through.
Yes.
You guys have found like a really clever way just to add some. I mean, there'll be more later, I know, but like right now, just adding ZK in to solve two very specific problems. And I like that because I think there's a lot more thinking that could be done on just adding in ZK, client-side ZK, to things like customer onboarding processes or the kind of use case that you've got. So you want to talk a little bit about where ZK fits into your broader application, and then Jack, we can start to have you join and talk a little bit about the technical approach.
Yes, great. So I'll go into three things here, kind of what we see our roadmap as being for introducing ZK into Snickerdoodle. So the first one was, in hindsight, it's very obvious. But when we were originally approaching the problem, it took us a while to figure it out. But right now we are using ZK snarks via o1JS. We are using that to directly replace the purpose of first and third party cookies. And so just reiterating here for the audience and anybody who might listen to the recording later, a cookie is just a unique number that gets automatically assigned to you, a human, that lives inside your browser, so that when you visit, you go from one site to another site, that unique number follows you around. And then when your computer starts talking to a business's backend servers, it sends over that unique number. And then it can look at, well, this unique number clicked on these buttons, or this unique number, looked at these products. And then without you being able to do anything about it, I can then record all those interactions against your unique number and build up a very sophisticated, holistic profile of what you do and what you like to do. So that's what a cookie does. Now, with a special ZK circuit that we built that implements what we call a proof of membership, you can do most of what you can do with a cookie, which is, I know that I'm interacting with the user who has an account or has used a particular business's application before. So that's what's called audience segmentation. Anybody who's interested about this general topic, you can look up audience segmentation. So I can be assured that I'm interacting with the user who's part of a given consumer audience. But when the user leaves and comes back, with our zero knowledge proof of membership, again, I know they belong to the specific audience that I'm interested in, but I don't know whether or not the session that just ended a few minutes ago, whether or not that's the same person. And so with a cookie, right, it's always the same unique number. So I can always know when it's the same person coming back. And then implicitly, I obviously know that they're part of the audience that I'm trying to target. But you're leaking a lot of privacy when you're just using a cookie and you're assigning you a unique number to a human that stays with them. With the zero knowledge proof of membership, it's a very simple circuit that we've implemented with o1JS. I get the important part, which is I know that I'm interacting with the user of a given audience, but I can't track them between sessions, which offers a high degree of privacy to your end user. So that's the first application. I consider it to be very fundamental. And at this point, I believe that if Snickerdoodle Labs hadn't done something like this when we did it, I think it was inevitable. Somebody was going to start using zero knowledge proof circuits to replace cookies. I think it was inevitable. But as far as I know, I think we were the first ones to do it.
Very cool. So it's kind of it's an inclusion proof. So it's a proof of membership of a set because you are proving that somebody is the right profile for a segment,
right?
But without having to communicate information about exactly who they are. And then it is what we call a nullifier, because it's proving that somebody, even though you don't know who they are, you can show that you haven't already counted them in a previous interaction. Is that fair?
So this is an important nuance that I kind of left off the original explanation. So once you've removed the ability to automatically determine whether or not this person that's interacting with my site is the same person from the previous session, well, then you've got the problem of, well, I call it like the double clicking problem. Like I don't want to receive the same information twice from the same user, but that then gets tough if I can't track users between sessions. So then how do I solve that problem? Well, the circuit that we developed with o1JS embeds implicitly what's called a nullifier inside of what's called a identity commitment. So when you start having this handshake back and forth between a user's browser and a business's backend servers, this nullifier component is what allows the business to do what's called deduplication of responses. So if I've got multiple tabs open, maybe on the same website, and tabs is sending responses over, well, I can't tell that the different tabs, which represent different sessions, I can't tell that they belong to the same user because I'm using a zero knowledge proof of membership. But I don't want to junk up my data set with responses. And so the proof of membership circuit includes what's called an identity nullifier, which is a little nuanced piece of it that solves this critical problem, which is I have to have a way to deduplicate responses for this to be useful. And so what we've done with our circuit that we built with o1JS, it does both of these things simultaneously.
Yeah, cool. And I like this because inclusion proofs or proof of membership are kind of fundamental to a lot of Zeek applications, as are nullifiers. So, people listening to this either now or on replay, those are great topics to learn up on, because they're some of the building blocks of some really interesting Zeek applications. Jack, let you jump in here and just talk a little bit about the deeper dive technical approach for Todd.
Yeah, of course. I guess what I would ask, just kind of in broad strokes, to give people a bit of intuition for what's actually going on under the hood, would you mind explaining, Todd, like what happens to the data, I guess, from the point that a user interacts with the website to the point that the proof is verified? Again, no need to go into a ton of detail, just kind of enough to help people build intuition for at what point sort of o1JS gets involved and what it's doing.
Right. So probably what I'll describe will sound like a nightmare of a user experience, but actually, if you see it in action, it looks anticlimactic. It looks like, did anything actually happen or not? But here's what happens. A user lands on a website. Let's just say they land on like a D app, their favorite D app, and they're going to do some trading, and they connect their wallet to the D app. Well, this D app, if it's powered by Snickerdoodle's analytics technology, what'll happen is when the user connects the wallet to the D app, our analytics package wakes up, detects, a user just connected, account 0x, blah, 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 whatever it is. It will then add that account to there's client-side profile, which is stored in browser storage, so it's stored client-side. Then our index, we have what's called an indexer layer to our analytics package that's again runs client-side. Our indexer layer wakes up, detects a new account was just added to this to my user profile. I'm going to suck in any information that I can find out about it from the various public blockchain networks. So then it reaches out to any compatible layer 1 or layer 2 that it knows about and pulls in things like the user's transaction history, what tokens does it own, what NFTs does it own, and then stores that in the user's very own local database. So the user is actually custodying their own Web3 data, and they're building up their own database about what they've done in the Web3 ecosystem. Now, once that happens, our Snickerdoodle package triggers a notification, a pop-up for the user that says, hey, this D app trying about what its users do across Web3 so it can better serve them. Message is customizable, but it gives them an opt-in, consent-first approach. Do you want to join Snickerdoodle, the Snickerdoodle data network, and share information with this particular business? Yes or no. If the user chooses yes, opt in, what happens is the Snickerdoodle package automatically generates an identity commitment, what I was just talking about a minute ago in relation to our proof of membership. It generates an identity commitment that, again, gets cached and stored locally as part of the user's profile, and then also relayed through an arbitrary gas relay to an identity commitment registry that belongs specifically to the business that's running the D app that the user just visited. So now you've got this identity commitment living in two places. Number one, it's living on your computer. And number two, It's living in what we call a consent contract that represents all of the identity commitments of that business's audience. Now, these identity commitments are totally anonymous. There's no being able to trace the identity commitment back to a particular human because they're totally randomly generated. Okay, so now you've got this identity commitment both on your computer and on the blockchain. At this point, when the business wants to know something about their audience, like what has the transaction volume across my audience look like over the past week, they can issue a network query to their user base they do this actually through their on-chain data structure, which hosts the identity commitments. They emit what's called an EVM event, which tells our analytics package, hey, when you're on the site, answer this question. Just answer this question automatically. When the analytics package detects this, it makes sure that the user's sharing permissions match or are compatible with what the business is asking, and says, okay, I'll tell you that. Generates the statistics that the business is looking for from the raw data stored on the user's computer, takes this, generates the zero-knowledge proof of membership with respect to the question that was issued by the business, and then delivers the payload, which includes the business insights plus the proof of membership and nullifier, delivers that to an arbitrary callback location. It's a decentralized technology. It's a decentralized protocol, so it doesn't actually have to go technically to Snickerdoodle Labs, our business tools. It can actually go to your own business tool if you want to build one really bad. But then it delivers all this to a callback location where the business can visualize this information, analyze it, but they can't track that information blob back to a specific user via what's called like a triangulation attack, where I ask multiple questions over time, different responses from the same human, and I know the responses all came from the same human. The zero-knowledge proof of membership precludes the ability to track responses of a given user over time, and that's the important part. But that's the cycle, right? A user just lands on a site like they normally do, connect a wallet, and all this stuff that I talked about, the identity commitment generation, the ZKP proving step, all this stuff happens on the user's device, but it's happening in the background without them having to take any steps to make it happen.
Yeah, this is awesome. And I think it also seems like this primitive can kind of be used in other ways. It wouldn't be hard to extend this into maybe something like, you could attach verifiable credentials in here, or even maybe use this for some kind of proof of humanity or captcha replacement.
Yeah.
If you can gather.
This is another area where I think there's a very on-the-nose, obvious application of zero-knowledge proofs that I'm personally kind of excited about. I'm sure everybody who's listening to this has encountered before a CAPTCHA, or the new fancy thing is called reCAPTCHA. These are, again, very, very basic internet tools that businesses use to try to prevent bots and click farms from screwing up their insights, their business tools. I think here is a huge opportunity, again, just like we replaced cookies with zero-knowledge proofs with the zero-knowledge proof of membership. I think there's a really straightforward use case for like a proof of personhood, or I've been personally calling it a proof of personal reserves, that could replace CAPTCHAs and reCAPTCHAs with a zero-knowledge proof that this entity that's interacting with your site, they control a certain amount of economic value, or they possess some kind of credentials that were issued by a trusted institution. So, let them through your gate because you know that they're probably a real person. I think this is another important area where ZKPs can be transformative, like overnight.
Yeah, this is really exciting. As we've been working on this, a lot of other people who are working on similar projects have opted to build sort of domain specific languages from the ground up, but he chose to do everything in TypeScript so that people can build applications that run, it's real TypeScript. It's not sort of like something that looks like
Exactly.
TypeScript and then gets transpiled into, who knows what. It runs at TypeScript runs. And so you can put it in an extension, you can put it in a website, you can put it in Node, or even like an Electron app if you wanted to.
Yep.
Yeah, so that's awesome. I kind of to that end, what was the experience like for you building this? I mean, I guess, do you like TypeScript? Maybe that's kind of a dangerous question. People seem to have strong feelings about that. But even if you don't like TypeScript, what did it kind of feel like to use o1JS and also the sort of associated developer tools?
Well, it was important for us. I mean, our particular stack is TypeScript. I mean, a lot of this stuff has to run natively in browser. So if you're doing it in TypeScript, you don't have to jump through too many hoops to get your stuff to run in a browser. So it was really important that o1JS was written natively in TypeScript. I mean, we assessed other ZKP libraries, like some people listening to this might be familiar with Circom. Circom was certainly powerful, but the developer lifecycle to get a Circom circuit into your browser app it's just not as straightforward as it is with o1JS. You got to write your circuit in the Circom language, which is fine, but you've got to really pretty much build every single little thing yourself. o1JS has some really nice primitives that if you had to write them yourself would be a pain and probably also be error prone. So our circuit that we use currently, it's really actually only 3 lines of o1JS. It's pretty much a 3-liner. If I had written it in Circom, it'd be much bigger. Additionally, if I was to write it in the Circom, I would then have to compile it into a WASM module, host the WASM module somewhere, write some kind of a wrapper around it, import it into the client-side iframe. Like it'd be much more difficult. With the o1JS approach, just native TypeScript, it's just a package. You build, you webpack your application and deploy it. It just fits into the normal developer lifecycle. So that was actually pretty important for us to keep the development costs, under control.
Yeah, this is great to hear. We sort of strive to have o1JS be as batteries included as possible. So, we have people on our team actually work every other Friday on kind of building, different primitives and things and including them in o1JS. And actually, for anybody who's a developer and who's listening, if you just go to the o1JS repo, there's some issues with things that would be cool to implement. And if you are thinking about contributing to o1JS, this can be a great way to get started. Phil, how are we doing on time?
We're nearly, we should be wrapping up pretty soon. So maybe, just a couple of, lightning round answers.
Cool.
Yep.
Yeah, to that end, on the subject of time, how long do you think it took you from sort of, the absolute beginning before you had installed anything or read through any documentation to the point where your application was kind of ready to go?
Okay, so I'm going to exclude the whole wrapping my brain around the ZK snark programming model because that's independent of that's independent of o1JS in particular. But just real quick on that, for anybody listening who's a developer that hasn't gotten their hands dirty in ZK snark land, it's a programming model. Just like smart contracts impose a new programming model and a new computational model, ZK snarks are a new computational model. And the secret is, at least for me, the catch is to understand that all you're doing is whatever your computation is you're trying to prove, you just got to write it as an algebraic circuit. And if you don't know what an algebraic circuit is, the Wikipedia page on that is great. But the key is, whatever your thing is you're trying to calculate, if you can write it as an algebraic circuit, you've solved the problem. If anybody here listening is in the optimization field, if you can magically pose your optimization problem as a convex problem, you've solved it. Idea here. If you can write your computation as an algebraic circuit, you've solved it. You have a zero knowledge proof. So once you wrap your mind around that, which can take, results can vary, right? Then getting onboarded from zero to having at least the proof of concept that showed that this was going to work. And that was doing other stuff, right? That wasn't entirely concentrating on just doing o1.js. But it took me less than a week from I'm going to make this happen and I know nothing about o1.js to I've got the proof of concept and it works. It works in our stack. It was less than a week.
That's cool.
Yeah, that's awesome. And to kind of tag on a bit to the algebraic circuit idea, if anybody here is familiar with just functional programming in JavaScript, I think it'll feel pretty familiar to you. You can kind of just dive in and the IntelliSense is really good for o1.js. We've put a lot of work into making the dot comments excellent. So
yep.
If you kind of run into something that doesn't work the way that you expect it to, you'll probably know immediately why it doesn't just by looking at the doc comments. I guess maybe two questions in closing. One is, maybe they go together. One is there anything that you're particularly excited about, either sort of with regard to your work at Snickerdoodle or just in general, that, zero knowledge proofs maybe can help facilitate? And then also kind of tagging on to that, you can o1.js has a sort of unique feature, which is recursion, which means that it can verify zero knowledge proofs inside of zero knowledge proofs, and it can do this in unlimited amount of times.
Right.
And I don't know if you've thought at all about maybe cool use cases for that, but I guess what's exciting to you about this in general?
Well, I think the more and more I work with zero knowledge proofs, it's like it's a game changer across so many industries. Like, I think people remember like the old laptops that used to have Intel CPUs in them, and you see the little sticker that says Intel inside. Like, I envision a computer where people like use that as marketing, like ZK inside, right? Zero knowledge, the applications are transformative in so many industries. I'm just excited about using ZK technology for all kinds of applications going forward. But particularly at Snickerdoodle Labs, there's a couple of things. One is offering like I really want to work on this idea I brought up earlier, which is like the successor to heuristics-based recaptchas, captchas and recaptchas. I really want to work on this. I think it's an important problem. Because these recaptchas, if you actually look into how they work, it's kind of creepy. They're basically monitoring every little pixel that you hover over. That's how they work. Okay, so replacing those with a ZK-based proof of humanity, either through proving that you have some sort of reserve economic threshold or proving something else, I think that's an important problem. And then towards your point on recursiveness, right? This is a more technical concept, but still important once you get into the nitty gritty of things. We're absolutely going to be using this property of o1.js at some point in the near future, because to do some of these things like we want to do with next generation captchas, ZK based captchas, maybe they'll call it Z captchas. No wonder what no telling what they'll call it, but ultimately it's going to require proofs about multiple aspects of an individual, and you're not necessarily going to have the opportunity in your UX flow. You're not going to have the opportunity to ingest all of the information at one specific time to generate your entire proof that's going to turn around and prove humanity. You're going to have to capture this information for the user opportunistically, which means I'll prove something when I have the chance to prove it. Well, then I want to link them together as I get them. Well, that's going to be a recursive approach. So if I need to, maybe I own some certain amount of Ethereum or USDC or something like that, then I prove that, maybe I visited some particular website. Maybe I prove that later on that I have some kind of KYC token issued by Coinbase. I'm not going to have all this information necessarily the first time a user encounters the ZK environment. I'm going to accumulate it over time, and then chaining those together is going to require a recursive approach so that you have a user experience that doesn't scare everybody off. So yeah, the recursive nature of chaining proofs together is going to be unavoidable to build decent user experience. And that's personally how I think about us utilizing the recursive nature. Is it's going to be a user experience technology for that reason. The reason that you don't have all the data necessarily at any given time, you've got to take advantage of it when you have access to it.
Yeah, this is
Cool.
so awesome. This is. Oh, sorry, Phil. Go ahead.
Oh, I was going to say, cool, thanks.
Yeah.
Yeah.
Well, to that end, I guess we should probably. Yeah, I mean it's cool because you can use it for incrementally verifiable computation, but you can also use it sort of like MapReduce, like on like a Hadoop cluster. You can,
Absolutely.
I think you could possibly literally use it on a Hadoop cluster to
100%.
do computation that's too big to fit on one machine, basically.
Yep.
Yeah, over to you, Phil.
Next week, we're going to be talking to Dia Data. And we've been working with Dia Data for quite a while now, just to define some potential new ZK Oracle, market Oracle use cases. It's actually an amazing space to talk about. There's so much that is constrained in the Oracle space today by having to work mostly on chain. And the use of off-chain verifiable computation is a huge unlock for Oracle. So that should be an interesting session. Please feel free to add questions to the Twitter thread, and we can look at those and respond there. Otherwise, thanks very much for joining, and have a great day, and hope to see you next week.
Thanks, everyone.
Thank you.
Thanks, everyone.